value of some number, right? And that's the concept that you're taught. And that's correct, and that's fine. It really is. But we're going to use another interpretation today. So I guarantee you that this is going to be something new, even if you've learned this already. Or maybe it's not, actually. I would love to hear that younger teachers are actually teaching it this way also. But it's usually a little bit new. It's an algebraic look at absolute value, not just a numerical look at absolute value. Okay, so let's go on to the first slide so we can see what we're going to right into. So first, I want to start with a simple definition. So when I think about this, I want you guys to think about absolute value as distance. As distance. And specifically as distance from 0 on the number line. So think about any number. If I put any number on the number line, the distance to 0 is just the positive value of that number. Even a number like -3. How far is -3 from 0? It's 3 units away. A distance is always a positive number. In physics, in 2 years from now, you're going to learn about distance versus displacement. They're different things. So here we're generally thinking about the concept of distance. So it's the distance between that value on the number line and 0. So first, the first example here is this. Take a look at this statement. It says the absolute value of x is equal to 1. Well, that simply means that x could be 1 or x could be -1. Because how far away is -1 from 0? Well, that's 1 unit away right here. Take a look where I'm pointing. And then this is also 1 unit away over here. So either 1 or -1 are 1 unit from the origin. 1 unit from the origin. So these are my equivalent statements. So this is true based off of this. So whenever I think about an equation where I have absolute value inside, I'm going to have a variable inside the absolute value, think of the fact that that variable can take on a positive or negative value. Maybe that'll be a whole expression in here. Maybe it'll be like the absolute value of 2x minus 7. Well, that absolute value, 2x minus 7, means that 2x minus 7 could equal 1, or 2x minus 7 could equal -1. So you're always taking whatever's on the inside, please take a look here, whatever's on the inside, and setting it equal to the positive or negative value of whatever's over here. It's a simple way to approach this. So you end up with 2 equations here. Here's your 2 equations. Again, had x not been x, had x been something like this, had it been 2y plus 4, what would it become? Okay.
So you would subtract 4 from both sides.
No, I got to do something first. Remember, we have 2 equations more. We have 2 equations here. Take a look at the setup above it. Take a look at the setup above it. X is no longer there. Now x is taken the place by 2y plus 4. What do you think? What would I get from that statement? Again, when the absolute value of x is equal to 1, I could say that x is equal to 1 or -1. It's one of the 2. But now this is taking the place of x, this whole expression. So what should I do with this expression, Isabella?
2y plus 4 is equal to 1 or -1.
Very good. So before you start solving, you have to set it equal to the positive or negative value. Because remember, whatever's on the inside of that absolute value could have been positive or it could have been negative earlier. But we know that the absolute value itself is equal to the positive 1, so the inside could have been 1 or it could have been -1. If this had not been a 1 right here, if instead of a 1, this had been like a 7 instead. Actually, let me just make that a 7 here. Let's make this a 7 in my red example. This would be -7 or +7. So make that a 7 here. That becomes -7 or +7. Whatever it's equal to tells us that that's what the distance itself is. So remember, again, whenever I have an expression inside of an absolute value, set that expression equal to the plus or minus of what was on the right-hand side. Okay, of what was on the right-hand side. Now the second portion here carries over from the first part. But instead of it being equal to 1, we're now told the absolute value of x is greater than 1. What's a number whose absolute value is greater than 1? Give me any number whose absolute value is greater than 1. 2. Give me another number. I'm going to be annoying, I know. 3, etc., right? So those are numbers beyond 1. And what -2, -3, -4. Those are all numbers whose absolute values would be greater than 1. So look at my graph. Look at my graph. I'm shading in technically this whole region, aren't I? All of these numbers would work because any number in this region outside of 1 and -1, beyond those extents, let me point here, every number outside here in that region out there, its absolute value or its distance, remember distance, how far is this distance from the origin? Well, that's about 2 units away. So that means that this is an absolute value of 2. So if I know that the absolute value is greater than 1, it's technically an OR statement. See how this is written? Remember when we drew this with the number line, we said these were OR statements, and we said that these were AND statements. So this is our graphical solution, which kind of lends us to this as our solution here. So this part is our solution here. So here's what I do, and here's how I remember it. It's a very simple, and I don't use tricks often, but I do use mnemonics to remind myself. So here's my mnemonic for this one. I think it will help a lot. So start by rewriting whatever you see the same way you see it. Just drop the absolute value. Okay? And then with the second inequality, negate it and flip the sign. Don't you remember when you multiply -1, what do you do with an inequality? Don't you flip the sign? Or when you divide by -1, don't you flip the sign? That same rule, keep that in mind. So when I make this a negative right here, I'll point. When I make this a -1 like we did earlier, I need to flip the sign. So this sign was greater than earlier, wasn't it? And because I made this negative, what do I make this? I make it less than now instead of greater than. So when you're looking at absolute value inequalities, like these next ones here, this next one here as well, so for or and statements, I have to remember to repeat what I see without the absolute value, and then switch to the direction of the sign and change the negation to whatever it is. So this one here, if I look at this, when is the absolute value less than 1? What kind of numbers have absolute values that are less than 1? Give me an example or give me a category, a name of a category of numbers whose absolute values are less than 1. Less than 1. What absolute values?
0.5.
Okay, so what kind of numbers are those then? What do we call them? Decimals. Decimals specifically that are between 0 and 1, I guess I should say. Okay, decimal values between 0 and 1. And they can be positive or negative. And take a look at my answer. Look at the graph. Look at the number line. It's all numbers between -1 and 1, which are pretty much all the decimals, not including -1 or 1. Not including them. Now, I use the same concept. I start with what I see here, and I start by repeating it. So literally repeat it again. There it is repeated. And then after that, what do? I flip the direction of the sign and negate whatever's on the right-hand side. So it's really the exact same process for all 3 of these, except when I have inequalities, I have to remember to flip the direction of the sign when I apply the negative parameter, if you will, or the negative portion, whatever you call that. Okay, so this started as a less than, it became a greater than when I negated it. It's very much just like when you multiply by a negative with an inequality, you have to flip the sign. That's really what you're doing, actually. You're technically multiplying the right-hand side by -1. Now, if you want to memorize or and AND, you can. Whenever you see here, whenever you see that an absolute value is greater than some number, it's going to be an OR statement. So if you want to jot that down, you can. But when it's an absolute value that's less than some number, it's always going to be an AND statement. You can memorize that, but I'm going to show you another way to come up with the answer that's actually probably easier. It's called testing regions. We're going to test regions for solutions. It's something that you will do in calculus, actually, with another technique, so it's a good preview of it. Okay, but you're welcome to memorize, because honestly, by the time I've taught this so many years, I have it memorized, that whenever I see a greater than symbol with absolute value, I know it's going to be an OR statement. I just know it's going to be that way. Okay, and the opposite comes about for a less than symbol. So let's jump to an example here. So the first one is an equality, right? An equation, not an inequality. So I know that the argument, let's all write that down actually, please. Let's write this down. This is called the argument. There's a phrase in math that means argument. It's like the thing that's inside of the operation. So if I had like x plus y, that whole thing squared, x plus y would be the argument. Okay, it's a phrase that's used a lot. Okay, argument. So the argument here inside the absolute value, that argument could be 14, or what else could it be? Or it could be -14. So So this is literally how we do these problems every time. This is the easiest topic of the year if you literally practice. That's all you have to do. So set the argument equal to 14, which we know it could be, or negative 14. And this is technically an or statement the whole way down, because I could have one answer or the other. And then just solve. That's all this involves. These are really not hard. Okay, you're literally going to do this every time. Now, mind you, I made this a little bit easy. If the absolute value is not by itself already, you have to get the absolute value alone. Right? You have to solve for it to get it by itself. So we could solve these two. I'll tell you what you'll end up getting here. You'll get 9 and negative 5. I'll let you practice that part on your own. You can all do that at your own. But what if I had this, please? Tell me what I would do. Take a look at the bottom, please. So if I have something like this, what do I do? And don't give me the answer, but tell me how you think of this. How do you think? What do you see when you see this? Like, what do you think of? What comes to mind?
Parentheses.
What do you mean?
Multiplication.
Yeah. So you think of these as parentheses, but the problem is that you can't distribute inside of here. So we can't treat them like parentheses. But I like the idea of parentheses actually, because that can lead us to something else in a second, which we will. You want to keep going?
Yeah. Do you have to subtract 1 first?
Okay. And then what?
And then do you divide it by 3?
Why? So what are you seeing this as then? I'm seeing this as a variable term. Look at the absolute value. See this whole thing as x or z. If this were 3z plus 1, you would do exactly what you said, right? So that's what I want you to visualize. When you see this happening, guys, I want you to treat this as if you see the following. So when you see an absolute value expression, treat it like a variable. You would normally solve for a variable, wouldn't you? You would get rid of the 1 and you would get rid of the 3. So do it the same exact way, please. Okay, so whenever you have a problem, we're going to go into a lot more than just this. So this is like the beginning of like the tip of the iceberg, because we're going to have square root functions. We're going to have cube root functions. We're going to have stuff that's way more complex than this. So the idea needs to be in your head right now. So I'm taking time to do this. Treat this as if you're seeing the whole expression that's inside there as a variable itself.
Should we graph it on the number line?
With a solution to an equation, there's no real need to do it. But an inequality, usually you graph on a number line. Yeah, it would just be 2 points on the number line, 9 and negative 5, closed circles at each spot. But I wouldn't go ahead and do that, okay? So I would take the root that Julia said, yes. And I would move the 1 over first, and let's just show what that looks like. That makes this a 9. This becomes 3x minus 5 still. So I'm solving this one, obviously, here. And then divide by 3. And now I can split this up into 2 equations like I did earlier in the first example. So now I'm going to make this x minus 5 equals 3 and x minus 5 equals negative 3. And then solve these both independently. This will become 8 and this will become 2. And if you go back to the beginning and try 8 or 2 here, they will both work. Okay, 8 and 2 will both work in the original statement. Questions, concerns, issues with that? We're going to continue this idea, yeah?
So what if you went and plugged 8 back in,
You'd plug it back in right here, yep?
then you would figure out what's in it and then
8 minus 5 is 3, 3 times 3 is 9, 9 plus 1 is 10. And the negative 2 just makes 2 makes it 2 minus 5, right? 2 minus 5 is negative 3. That absolute value is 3. 3 by 3 plus 1 is still 10. Okay, so you try both answers in the original, okay? There are going to come times where both answers will not necessarily work. So keep that in the back of your mind, okay? For a lot of these, they're absolute value, there will come a time when it will not work, and we'll point those out. Quick look at the second one now. Please focus on this class, please focus. Absolute value of the quantity 6 minus 4u is less than 5. So it's the same thing as the last one, but instead of equals, now it's just less than. So treat it like you did the last time. Okay, if you need to go back to that first chart, you can. Or you could remember just to break this into pieces. So repeat it to start. And then on the second one, repeat it, but go ahead and flip the sign and change the negation on the right. If it is negative, make it positive. If it is positive, make it negative. So again, I'm repeating it in red, and then I'm flipping the direction of the sign and changing the negation on the right in blue. And then you're just solving these. That's all you're doing. I can tell you already, because it's a less than, that this will be an and statement. I remembered that less than or and statement. But if I didn't remember it, it's not a big deal. We can absolutely come up with that. You have an answer or a question?
I have a question.
Yeah.
So if it's an or statement, but they go towards each other, I'm turning it into an and statement.
If it's an or statement and they go toward each other, the answer is all real numbers. Think about it. Because what does or mean? It could be this solution, or it could be this solution. So you're saying when they overlap, right? The answer is all real numbers then, right? Because if it technically or means it could be one or the other. So any part of the line would work here. So I would not fill in and or yet. I would actually just write it out and let's see what happens here. Okay? So let's actually write it out and see. So when we do this, I'm going to move the 4u over, move the 5 over. That becomes a 1 less than 4u. Then u greater than, I think it looks like 1/4. Agreed? I move the 4 over in that. And the same thing on the next one. I'm going to move the 4u over here by adding it over. And I'm going to add the 5 over to make that 11. And that'll be u, and that's going to be 11/4. So those are the two statements I end up getting. You see why I'm doing it the way I did it? I don't like to divide by negative in inequalities. So if you don't move the 4u over, you have to end up dividing by -4. So I moved the 4u over here, and I took the -5 and added it to 6 over here to make it 11. I just kind of did it all in one step. You can move two things at once, right? Start doing that more and more. Your algebra should be kind of quick at this point. You should almost be doing this in your head. I'd love to see a step along the way, though. Okay, for those that don't show too much work in your test, especially, show me a little bit. But a lot of that can be done in your head. So a hand pop up.
I was just going to ask how come signs are inverse, but it was because I divide by negative.
Exactly. But you got the same answers, though, didn't you? Which is interesting. So if you prefer not to divide by a negative, I would always move the negative if it has a coefficient for the variable to the other side. So we have u is greater than 1/4. So let's draw this out, actually. So here's 1/4, and here's 11/4. Right? I don't know, specifically how far apart doesn't matter, but as long as I know that 11/4 is more. So u greater than 1/4 is this. U less than, I see why you asked that now, Maura. Okay, I understand what you're saying. U less than 11/4 looks like this. So if we take a look at this answer here, we're seeing an overlap of two sets, which usually indicates it's an and statement, and it is an and statement here for sure. But was your question, Maura, how do you really recognize that it has to be an and statement?
Yeah.
Because technically it could be an or statement. If this is true, or this is true, then all numbers would be possibly true, right? So I see what you're saying there. It's always going to be an and statement when it's a less than. I know that because if you go back to the definition of absolute value with the distance from the number line, we know that it's all streaming from that number line. It has to be less than. So a less than symbol to start is always going to be and, so maybe that would be something good to remember then. Earlier I said maybe it's like somewhat useful, but I guess it would be more useful than it seems. So the overlap of these two sets occurs between 1/4 and 11/4 exclusively. How do I write that in solution set form? How do I write this answer in solution set form? I could use the word and, but instead of using the word and, give me like one long statement that I could write.
You could say 1/4 is less than u, which is less than 11/4.
Very good. Okay, if I wanted to write it specifically, and a couple of you asked about this, because I guess you learned it this way when you were younger, you could write it like this also, which is fine. Inside the solution set brackets with u being the domain of interest. Okay, u takes on those numbers. How would I write this in interval notation? Interval notation, which some people still struggled with on the test. Interval notation, what would it look like? From 1/4 to 11/4, not including those endpoints. What's the key here? Francisco? Yeah, close parenthesis, I got you. So no brackets here, okay? And although that looks like a coordinate, based on the context of the problem, I know it's not. It's an interval. It's not a coordinate, right? Coordinates are written exactly the same way, so they're going to look just like that. At least when they have brackets, it's obvious, right? With the parentheses, it could be a little misleading that this is an interval that U takes on. U ranges from 1/4 to 11/4 exclusively. Okay, let's try this next one. So in the previous couple examples, in the last example we had a less than. Now we have a greater than. See how I've drawn it? I've kind of reversed the equation. Read it this way, please. Read it from right to left. This absolute value is greater than or equal to 3x. So this is a greater than statement. Is that clear what I'm saying here? Read it from the perspective of the absolute value first. So start on the right and read that way. So it says the absolute value of 2 plus 1/2 x quantity is greater than or equal to 3/2. So I start, again, by repeating the absolute value and negating and switching the constant on the other side. So here's the regular one I'm going to write down. And if this confuses you, switch the order. It's fine. You could write it backwards if it helps. And then the second one is going to be the negative part. And I flip the order of the sign. So again, remember, you're repeating the argument. The argument never changes. The argument never changes. That's always going to be repeated. It's the sign that flips, and then the constant sign itself on the other side that flips, or changes. Solve these separately, right? What's the easiest thing to do right away for both of these equations to make life much better? Right off the bat? Yeah, I would just double everything. And notice the argument, when you double it, becomes the same on both sides, so you don't have to do it twice, right? It's very easy to do that. And then go ahead and solve. It just makes life a lot easier to do it this way. For those that have trouble with time on tests, this is good to know, right? Especially because you take these tests in my class, and then wait till you take your SAT and like a subject test. You have 50 minutes, or 50 questions in 60 minutes on a subject test. That's like a minute a question. If I gave you guys, think about it, I would be like me giving you 35 questions on your test. I want to give you like maybe 12 to 15. Granted, 3 of them are word problems, but you know what? On the SAT, a lot of them are all word problems. And you literally get like a minute a problem. So consider that, right? For test taking strategies, you want to have the fastest route possible. Doubling and going through it this way is much easier. Okay, x greater than -7, less than or equal to -7 is this way. X greater than or equal to, you can start backing up. Greater than or equal to -1 is this way. So just look at the answer right away. You know it's an or statement based on the direction of the arrows. Again, less than or equal to -7, greater than or equal to -1. So do me 2 favors tonight. Please watch the last 2 examples and finish these. We'll go over them tomorrow to start, but please do the homework also. Okay, so you have examples 4 and 5 to finish up on. Either you can watch the video under Mr. Howell's videos, or at least go to my notes that are filled in, and you'll see this right here, literally, and you can go step by step through it. If you prefer to read through it, you understand instead of the notes, that's fine. Okay? Have a good day, guys. Please check in with me when you can. Office hours tomorrow morning or tomorrow after school. I will not be here today after school, just so FYI. Okay, tomorrow morning or after school for office hours, please.